All right, let's do volume and surface area for the warm-up today. Volume for a cone, 1/3 pi r squared times the height. What are we putting in for the radius? 3. Oops. Here's our radius. So 1/3 times pi times 3 squared times the height. What is the height of this cone? 9. So 1/3 times pi times 3 squared times 9 gives us what for the total volume? How much? 84.823. Do we need units with that? Inches, inches squared, inches cubed. Inches cubed, yes. Very nice work. All right, and then surface area. To find the surface area, oh, come on. We need the area of our single circular base, pi r squared, plus our lateral area, which is pi r times our slant height. Do we have all the pieces that we need to do our surface area? What do we not have? We do not have our slant height. That would be right over here. All right, so let's find that slant height. A squared plus b squared equals c squared. What do we put in for a and for b? 9 and 3. So we have 9 squared plus 3 squared. Order does not matter there. The 9 and the 3 can be switched around. Equals my slant height squared. So 81 plus 9 equals my slant height squared. What is 81 plus 9? 90. So I have 90 equals my slant height squared. Then we take a square root of both sides to cancel out the squared on our slant height. Is the square root of 90 a nice, pretty whole number? Nope. So we're going to just leave that as square root of 90 when we go to substitute it into our formula. So surface area, pi times our radius of 3 squared. This is the area of that single circular base. What is that area by itself? Pi times 3 squared. Pi times the radius squared. (28.274) plus our lateral area, the funnel-shaped piece, pi times our radius of 3 times our slant height of radical 90. What do we get for that part? 89.411. And then we have to add those two together. I got 117.685. What kind of units? Inches squared. Very nice work. So please remember, because I'm seeing this come up a couple more times, and this is going to become really important in the next several days, our surface area formula has two parts to it. and I need you to be able to identify which part is which. For a cone, pi r squared, that's the area of the circular base. The other part of it here, pi r times my slant height, that's how I get the surface area of the sides of the funnel-shaped piece. We call that the lateral area. So we have our base and our lateral area. All right, let's switch into your notes. We're going to be on page 10 in your notes. And our focus for today and a portion of tomorrow is the volume and the surface area of spheres, or a ball shape. So that's what we're showing right here. This is a sphere. My sphere has a center. It has a diameter that runs from edge to edge. And it has a radius that goes from the center to that outside edge. A cross section of a sphere, if I were to slice a portion of the sphere off, is going to leave me with a circle. This is the intersection of a plane and a sphere. Half the sphere we call a hemisphere. And if I take a plane through a sphere right at the center, right here, we call this a great circle. This is a cross section through the center of the sphere. The great circle cuts my cuts my sphere into two hemispheres. What would you call this object right here? That is a hemisphere, yes. All right, let's talk about volume and surface area for a sphere. Volume for a cone, 1/3 pi r squared times the height. Volume for a sphere is very, very similar. My fraction out in front is going to be different. But also, I want you to look at this. Here's from the center to the edge. So here's my radius. That's what I would take in square, right? What about if I do the height? What do you notice about the height? It's exactly the same. It's another radius. So instead of having r squared, what would we call it if we had r squared times another radius? How many times would r be multiplied by itself then? 3, so that would be r cubed. My volume formula for a sphere is 4/3, not 1/3, pi r cubed. So basically the volume of a sphere is the volume of a cone 4 times over. We could fit the same volume of 4 cones into one sphere if their radii are the same size. And the height is the same as the radius. All right, so 4/3 pi r cubed. Surface area. Surface area for a sphere is related to my area formula for a circle. Area formula for a circle is pi r squared. Surface area is 4 pi r squared. So the surface area of a sphere is 4 times the area of the great circle of that sphere. So the only measurement that we need to know about a sphere is what? If we're going to calculate the volume of the surface area, what's the only piece we need to know about that sphere? The radius. Radius is the only piece we need to know. If they give us the diameter, we can find the radius. But we have to have the radius in order to move forward. Okay, let's flip over to page 11 and try a couple examples. All right, we have a soccer ball here. It has a diameter of 23 centimeters, but I don't want the diameter, I want the radius. How do I find the radius if I have the diameter? Divide it in half. We take the diameter, divide it by 2. 23 divided by 2 would give me what? 11.5 centimeters for my radius. All right, now we're going to find the volume. 4/3 times pi times my radius of 11.5 cubed. What is the volume of this soccer ball? What is the volume for this soccer ball? If you need help finding the cubed key, please let me know. I'm happy to show you how to put that into your calculator. $6370 point how much? 62 and after the 2? There we go. 6,370.626 centimeters cubed. All right, let's find the surface area. Surface area for a sphere is 4 pi r squared. So surface area for this sphere would be 4 pi times my radius of 11.5 squared. What is our surface area? Can you read the digits one more time? 0.90, and what comes after the 0? 2, and after the 2? A 5, so that 5 is going to make my 2 round up, so 903. 1,661.903 centimeters squared. I would like for you guys to try the baseball. Take about, let's do about 2.5 minutes there. Yes, perfect. What is the radius of this baseball? 3.7. We take our diameter of 7.4, cut that in half, and we get 3.7 centimeters for our radius. What did you get for the volume? So for the volume was how much? 212.175, yes. 4/3 times pi r cubed. So 4/3 times pi times 3.7 cubed comes out to be 212.175 centimeters cubed. What about the surface area? What was your total surface area for the baseball? 172.034 when we take it out to 3 decimal places. 4 pi r squared. So 4 pi times 3.7 squared. And we get that total surface area of 172.034 0.034 centimeters squared. Very nicely done. All right. Let's look at number 3. What did you guys call this shape again? Hemisphere. It is half of a sphere. We want to find the volume of that hemisphere. So if I'm going to do half of a sphere instead of the whole thing, my volume formula for a sphere is 4/3 pi r cubed. Well, what is half of 4? 2. So we're going to do 2/3 pi r cubed, because this is half of 4/3. What is the radius for this hemisphere? Radius is 2. So let's go ahead and substitute in. Volume is equal to 2/3 pi times 2 cubed. Pop that in your calculator and tell me what you get. (16.755 centimeters cubed). Surface area for my half a sphere. Well, the surface area formula for a whole sphere is 4 pi r squared. How do you think that's going to change because I'm looking at just half? 2 pi r squared, absolutely correct, because this is half of 4. All right, so let's substitute in, see what we get. You said how much? 25.133. Give me just a second, I'll get that written down. Surface area, 25.133 centimeters squared. So that's the surface area of half the sphere. I want the total surface area. The surface area of the hemisphere and the circular base. So surface area for hemisphere plus the surface area of the great circle. Well, I already know for the hemisphere, I have 2 pi r squared, or 2 times pi times 2 squared, which was 25.133. Surface area for the great circle. How do we find area for a circle? Pi r squared. And what is our radius here? 2. So pi times 2 squared. What is pi times 2 squared? 12.566. So my total surface area for these two pieces put together, the outside curved portion and then that flat circular portion, would be 37.699 centimeters squared for my total surface area. Very nicely done. All right, the homework that you guys picked up on your way in the door is due on Thursday, but we have covered everything we need to with spheres. There is nothing on that homework that you cannot do at this point, but it will be due on Thursday. Tomorrow we will start the last section that we need to in this module. It is over composite figures. So we're going to take cylinders and cones and stack them on top of each other, or take half of a sphere and put it on top of a box. And we're going to find the volume and the surface area of those particular shapes.